Okay, hello everyone. Myself Supriya Ghadke. Okay, so I am Assistant Professor with the Pratishthan's Kamal Bajaj Institute of Engineering and Technology, MIDC Baramati. So today I am discuss the vector differential calculation. That is the lecture number 2. So in that lecture we discuss about the gradient, divergence, and curl. So we start from the scalar point function and vector point function. So what is the scalar point function? Okay. So here scalar point function. So what is the scalar point function? Is scalar quantity phi depends for its value on its position, say xyz in space, then phi xyz is called the scalar point function. So that is defined by the phi xyz. So that is the scalar point function. I repeat the definition. If the scalar quantity phi depends for its value on its position, say xyz in space, then phi is said to be scalar point function. So examples of the scalar point function is temperature, then density, potential. Okay, so these are the examples of scalar point function. Now next is the vector point function. So vector point function, if the vector quantity f bar depends for its value on the position xyz in space, then the f bar xyz is called vector point function. So that is denoted by capital F bar of xyz. So that is the vector point function. And for example, velocity, force, electric density are the examples of vector point function. So now we have to define just operator. So that is known as the del operator. So del operator. So that is denoted by that symbol del, or we say that operator as a nebula. So but we call as a del. Okay. So del operator is nothing but, so we can define that del as I times delta by delta x plus j times delta by delta y plus k times delta by delta z. So just we have to write I bar, j bar and k bar here. So that is our operator, so del. So if we apply that del on scalar point function, so scalar point function is phi here. So if we apply del on phi, then we get the result. So that result is known as grad phi, okay, or gradient of phi. So so gradient of scalar point function is grad phi. So that is known as the gradient of phi. So that is I times delta phi by delta x plus j times delta phi by delta y plus k bar times delta phi by delta z. So that is known as the gradient of phi or grad phi or del phi. So that is the very important concept. So that concept is required for finding the directional derivative. So So we discuss about the directional derivative now. Directional derivative. And directional derivative is defined by grad phi into a hat. Okay, so that a in the direction of a, so we have to calculate that a hat. So by using that formula we have to find the directional derivative of that vector. Mm, so now we just find the maximum magnitude. So to find maximum magnitude, is nothing but the mod of del phi. Okay, so that is the main result. So by using that result, we have to find the directional derivative. So one problem is we have to solve. Find the directional derivative. Find the directional derivative of phi. So phi is given as phi is equal to xy square plus yz cube at 1 minus 1 1 along the vector I bar plus 2j bar plus 2k bar. So that is the problem. Here we have to find the directional derivative of phi. So phi is given as xy square plus yz cube at point 1 minus 1 1 along the vector. So that is the vector. That vector is nothing but a bar. A bar is given here. I bar plus 2j bar plus 2k bar. All the time that a bar is not given to us. In some problems that are given, or in some problem we have to calculate that a bar now. So here just we have the value of a bar. So just we have to find here del phi. So to find del phi, so del phi is nothing but I bar times delta phi by delta x plus j bar times delta phi by delta y plus k bar times delta phi by delta z. So that is I bar times delta phi delta x of. So phi is x y square plus yz cube plus j bar times delta phi delta y of xy square plus yz cube plus k times, so k bar times, here is bar sign, so delta by delta z of xy square plus yz cube, so that is equal to r by times. So with respect to x, that term is constant, y and z is term constant with respect to x, so that derivative of that term is 0. And here with respect to x, derivative of x is 1, y is take as a constant, so that is y square plus here j bar. Here derivative with respect to y, so here is 2xy and here is plus z cube plus k bar times with respect to z, so that term becomes constant and derivative of this term is 3yz square, so that is our del phi. Now we have to calculate that del phi at point 1 minus 1 1, so we have to calculate that term. So I just write here our del phi. So del phi is y square I bar plus 2xy plus z cube j bar plus 3yz square k bar. Now we have to put the value here. So that value is 1 minus 1 1. So we get answer I bar minus j bar minus 3 k bar. Just we have to put x, y, z as 1 minus 1 1 respectively. Okay, so we get that vector I bar minus j bar minus 3 k bar. So here a bar is already given to us. So a bar is here I bar plus 2 j bar plus 2 k bar. So just we have to find a hat. So a hat is nothing but a bar upon mod of a bar. So a bar is I bar plus 2j bar plus 2k bar upon root of 1 plus 4 plus 4. So that is equal to I bar plus 2j bar plus 2k bar upon 3. So now that is a hat. We have del phi, also we have a hat. So now directional derivative, that is denoted as capital DD. So that is equal to del phi into a hat. So del phi is I bar minus j bar minus 3k bar into, here is dot product I bar plus 2j bar plus 2k bar upon 3. So dot product is nothing but the product of coefficient of corresponding coefficient corresponding ijk's. Okay, so 1 into 1 by 3. So here is 1 by 3 minus 2 by 3 minus 2. So that 3 3 get cancelled. So that is nothing but the, so here is 1 by 3 1 minus 2 minus 6. So that is equal to minus 7 by 3. So that is our directional derivative. Okay, so that is one type of problem. Now second, sometimes one point is given and just we have to find the a bar. So same question is here, find the directional derivative of phi. Phi is same, just we'll write here, phi is x y square plus y z cube at 1 1 1, at 1 minus 1 1, towards the point 2 1 minus 1. So here a bar is not given. This here we have to calculate del phi into a hat. Okay, so that is directional derivative. So del phi is already we calculated at point 1 minus 1 1. So I can directly write that value. Just we this value you can find already in previous example. So that value is I bar minus j bar minus 3 k bar. Just we have to find here a bar. So to find a bar, here is the 2 points. So that is the this is our initial point and this is the final point. Initial point is 1 minus 1 1 and final point is 2 1 minus 1. Suppose that is a and that is b. So we have to find a bar is a bar, b bar minus a bar. So that is a bar is equal to 2 minus 1 I bar plus 1 minus minus 1 j bar plus minus 1 minus 1 k bar. So we have to subtract that term, 2 minus 1 1 minus minus 1 minus 1 minus 1. Okay, so that is I bar minus minus plus 2 j bar minus 2 k bar. So that is our a bar. Now we have to find a hat here. A hat is a bar upon mod of a bar. So after calculating that values, we get a bar is equal to I bar plus 2j bar minus 2k bar. So a hat is equal to I bar plus 2j bar minus 2k bar upon root of 1 plus 4 plus 4. So that is equal to I bar plus 2j bar minus 2k bar upon 3. So directional derivative is equal to dt is equal to del phi into a hat. Del phi is nothing but I bar minus j bar minus tk bar dot a hat is I bar plus 2j bar minus 2k bar upon 3. So taking dot product here, we get that 1 by 3. Take outside here, 1 into 1, that is 1, minus 2, minus minus plus 6. So that is 7 minus 2, that is 5 by 3. So that is directional derivative. Okay. So thank you for watching this video. If you don't subscribe the channel, please subscribe channel to view more videos regarding this MT M3. So thank you for watching.